Hi all, this is the first time I've done a recording like this, so please forgive me if it's a little bit messy and a little bit scrappy and I say a lot. Also, I think I ought to apologise straight away. I've got two terriers, so if they start barking, that's completely outside my control and I'll try and just talk over them. Okay, this movie is, I've used Unity 3D to try and simulate the eclipse that we're expecting to see on August the 21st of 2017. What I have found is that the moon here, which is, as you can see, looks roughly equal to the distance when you draw these things out ratio-wise as the moon is to the Earth in reality. So, funny enough, it actually seems to work relative to the real world measurements that people seem to use. I've set up a camera quite close to the Earth so that we can see the rotation, and I've placed these moon objects inside a standard moon holder so that I can rotate it once and it will rotate them all equally. And as you can see, the furthest moon from the centre of rotation, which will be the Earth, is travelling a lot faster than the item closer. That actually becomes quite important when you think about the speed of the shadow that passes over the Earth, when I'll show you in a minute. Some things you ought to know. I've set up each time slot rotation as 15 degrees for the Earth and half a degree for the Moon. That's relative to a 27-day period being 0.55555 recurring for the Moon. So I just said, you know what, just do it as 0.5. For what we're doing here and for the purposes of what I'm trying to prove, that's fine. So if I press play, you should see 4 moons. Oh, sorry. Never mind, just take my word for it. The big glowy bit down the bottom there is a parallel light source, so it's just basically a wall of straight line light. So as you can see, the faster, the moon that's furthest away from the point of rotation passes over the Earth exactly as we would expect on August the 24th. So that's that 4th moon there. Because of it travelling faster and because of the way that shadows work from a parallel light source, it is also travelling a lot faster across the surface of the Earth, and you can see it even kind of dips up and then goes back down relative to the actual map of the USA, and it does go from east to west. Now if I do this by hand, just bear with me because I have to mess about zooming in and moving the mouse and rotating around and things. So basically I'm just trying to line myself up to be able to see the Earth a lot easier. Take hold of the moon rotator, and you see how it's just purely because of the speed, because of the radius of the Earth, the moon, that it will travel across the surface of the Earth very fast compared to one that's a lot closer, such as that item there. So if you look at the actual overall distance for these things, it kind of makes sense to what you would expect to see. The moon is quite a long way away from Earth, apparently. You know, now obviously I didn't need to make that sun 93 million miles away because it's just parallel light at this point anyway, so a directional light was fine to use it within Unity. Now with regards to the speed, when people are talking about the moon travelling roughly twice as fast as the surface of the Earth, it actually is. I did some research into this. It's quite commonly known that it's about 1,000 miles per hour for the Earth's surface at the equator. So I did a little bit of research into how far the moon was from Earth. I put it into a spreadsheet and it's 27 days. So the circumference of a circle, which is the total period of time that it would take to travel around the Earth. Come on, wake up. Not just typical when you're recording, which I knew, but just to prove it to you guys. So radius plus radius times pi will give me the total distance travelled in any 27-day period for the moon. Multiply the number of days by number of hours to get how many hours that is, and then divide that distance by that many hours to get the distance per hour. And it turns out that it's 2,316 the way I've calculated it. Granted, I've not used decimal places and I'm doing a very quick, dirty video on this. So I estimated about 2,300 miles now. So yes, that is roughly double what people estimate the moon to be traveling compared to the surface of the planet. So then when I went and actually looked up at how fast the moon is traveling, it's 3,683 kilometers, which is 2,288 miles. So my rough and ready calculation wasn't too bad. It's in the right ballpark, considering that I've done very rough numbers and not zeroed, not accounted for decimal places and what have you. So I don't know what else to show you on that. I think that definitely does explain it. I think you definitely did see it from a decent enough angle, didn't you, to see that it would actually do it. Do you know what I am going to do? I'm going to get rid of those three and then just show you with the one, because then you'll see exactly what we're getting at and what we're expecting to see. Oh, did I not pause it properly last time? There we go. Let's try again. What's happened there? Took a lot of setting up to do this, lots of trial and error getting it to all line up properly. So if it's not lined up properly, that's the kind of problem you come across. So it should do it right this time. Should see it flick in, come across from the east, curve back down towards the west. I've said that the wrong way, haven't I? Comes in from the west and curves back over towards the east. So there you go. That, I believe, is how the eclipse on August 21st will work in a heliocentric model. So sorry to all you flat earthers, it is possible on heliocentric.